This is lesson number 1 for pre-calculus. These lessons follow a book by Ron Larson that's called Pre-Calculus with Limits, right here. Pre-Calculus with Limits by Ron Larson. Okay, the first one here we're doing using slope. Use the point on the line and the slope of the line to find 3 additional points through which the line passes. All right, so you might be thinking, well, I know how to do this. This isn't pre-calculus, but all classes start with review, so this one starts with review too. So it wants us to find 3 additional points that passes through the line. It always helps to draw what they talk about. Here they said we have a point -4, 1. So there's -4, 1. It says the slope is undefined. Remember that an undefined slope is a vertical line. A horizontal line has 0 slope. And then sometimes people have trouble remembering the difference between vertical and horizontal. I always like to say that horizontal has the word horizon in it, like the sun coming up over the horizon. So horizontal, horizon. So the slope is 0 because you put a car on it and it's not going to go anywhere if it's on a gas. It just stays right there on the line. It's got 0 slope. And then undefined is a line that has a vertical slope of going straight up and down. And if you try to put a car on that, it's just going to slide off of there and crash. So that's kind of undefined. All right, so it's going through the point -4, 1, and it's got an undefined slope, so it's a vertical line. And they would like to have more points on that line. Well, for all of those points, the x is going to be -4. So you could have -4, -6, -4, +10. But any point, as long as the first number is -4, works. So I'll do -4, 10, -4, 15, because it says they want to have 3 additional points. All right, so -4, 5. So there we go. There's 3 points. Okay, same question on the next ones. Again, it helps to draw a picture. So drawing a picture, we're going through the point -5, +4. And then it's got a slope of 4, so it's 4 over 1 since it's not over anything. Remember, slope is the change in the y over the change in x, or the rise to the run. It rises because the y-axis goes up and down, and it runs because the x-axis goes left and right. So from that point -5, 4, we're going to go up 4 and then over 1. And so up another 4 and then over 1. So in other words, we're going up 4 for the y number each time. So it started at -5, 4. So if we're going up 4 for the y, it's going up to 8 and then 12, then 16. And we're going to go to the right 1, so we're adding 1 onto the x, which takes it to -4, -3, -2. So there's 3 more points for it, which you can see from what I graphed. And if you use a better piece of graph paper, like this kind of graph paper, you'll be able to count it better. It's hard to count it when you graph it by hand like this, not on a grid. All right, the next one. The point-slope form of the equation of a line. Find the equation of a line that passes through the given point and has the indicated slope. Sketch the graph by hand. Use a graphing utility to verify your sketch if possible. Okay, so they gave us the slope and they gave us the point. That's kind of step 1. Figure out what a point is and figure out what a slope is. And once you got a point and slope, then what you're going to do, I like to plug it into the point slope formula. Y minus y1 equals m times x minus x1. So plugging in the x and the y, remember it goes in alphabetical order, x, y, z. The x is -2, the y is -5. So y minus -5 equals that slope is 3/4 times x minus -2. So that's x plus 5 equals 3/4 x. And then 3/4 times -2, distributing it across here, gives you 6/4 plus 6/4. And then I'm going to move the 5 over to make it -5. So then y equals 3/4 x. And the common denominator here is going to be 4, so I'm going to change that to 20/4 by multiplying the top and bottom both by the number 4. And then +6 and -20, different signs subtract. And so that makes -14/4. or reducing it, that gives you 7/2. All right, so there is the equation of the line, and it says to also sketch it. Now this is the equation in point slope-intercept form. This was also the equation of the line in point slope form. Depending on what point you have, you're going to have a different variation of it, but whenever you clean it up, it always comes to the same answer here for the points for the slope-intercept form. So it's always nice to just put it in slope-intercept form so you can check your answers to see whether they're right or not. All right, so it said to graph it by hand, sketch it by hand. So sketching it by hand, it's got a y-intercept. So that's kind of step one. We'll call it step A. Graph the y-intercept, -3.5. Then use that slope, 3/4. That's the second part, or part B. I'm going to count up 3. 1, 2, let's see, 1, 2, 3, and then over 4. And again, they said they'd check it on the calculator, so let me put it in the calculator for us. Remember, on the calculator, you go to y equals, and it was 3 divided by 4x minus 7/2. And then you hit graph. And then you can go to the table if you want and see some of the points to graph it, or yeah, to graph it by hand if you wanted. All right, on the next page, it says using the slope-intercept form, determine the slope and y-intercept if possible of the linear equation, and then describe its graph. Well, if we want to find the slope and the y-intercept, we want to put it in slope-intercept form, y equals mx plus b. Remember, because m is the slope and b is the y-intercept. So solving this for y, it's -3y. So move the x and the -9 to the other side, and when you move it to the other side, it changes signs because you're adding the opposite of it to both sides. So all you have to do is just change a sign when it crosses the equal sign. So it makes -3y equals -4x plus 9. Last of all, to clear away the -3 on the y, everybody gets divided by the -3 all the way across. So that makes y equals +4/3 x minus 3. So now that it's in that form, we can say that the slope is 4/3, because that's the number in front of the x, and then the y-intercept, which is the b, is -3. I guess it says to describe the graph. Let me see. It's got the y-intercept of -3. It's got a slope of 4/3. So describing the graph, I would say it's a line with a positive slope, and it's rising from left to right. It's rising up because of the positive slope. And just say it's got that y-intercept of -3. Next up, using the slope-intercept form, find the slope and y-intercept if possible of the equation of the line algebraically, and sketch it by hand. So it's the same question again. If we want to find the slope and the y-intercept, we need to put in y equals mx plus b form. So I'm going to isolate that 3y, move the 2x over and the 9 over to the other side. So it makes 3y equals -2x plus 9. Divide everything by 3. So then y equals -2/3 x plus 3. So the y-intercept is 3, and the slope is -2/3. And they said to sketch it by hand. So again, the y-intercept is +3, and it's got a slope of -2/3. So down 2 and right 3, down 2 and then right 3. All right. The last one, parallel and perpendicular lines. Determine whether the lines L1 and L2 passing through the pairs of points are parallel, perpendicular, or neither. Recall that when the lines are parallel, they have the same slope. When they're perpendicular, they have negative reciprocal slopes. So, for example, 3 and -1/3 are negative reciprocals, 2/3 and -3/2 are negative reciprocals, or -4 and +1/4 are reciprocals, and 0 and undefined are reciprocals of each other for parallel and perpendicular lines. All right, so the slope of line 1. Again, change in y over the change in x. So the change in y, 5 minus negative 1 over 1 minus negative 2 gives you 6 over 3, or 2 for the slope. In line 2, when you do the change in the y over the change in x, negative 5 minus 3 over 5 minus 1 gives you negative 8 over 4, which is negative 2. So they are different signs, but they're not reciprocals of each other. It would have to, for the number 2, the negative reciprocal would have been negative 1/2. So there's some things here that you should memorize and maybe make some flashcards over. So on the front, we talked about horizontal and vertical lines. So you might want to make some flashcards about what a horizontal line is for the slope and what a vertical line is for the slope. And we talked about what the slope is, a change in the y over the change in x, or y2 minus y1, x2 minus x1. That's a formula you need. I gave you the slope-intercept, the point slope formula right here. This is point slope. That's a good flashcard too. And then on the back here, down here on the bottom, we talked about parallel and perpendicular lines. Parallel has the same slope and perpendicular have negative reciprocal slope. So again, possible flashcards for you. You don't really get any formulas at all on the ACT test. So on the SAT test, they just give you a few that you really don't need. And then on top of that, when you go to college, they're not going to give you a formula sheet when you take pre-calculus or calculus. So these are things that honestly you're just supposed to know. So make some flashcards and memorize them. All right, again, this lesson follows the Larson book, Pre-Calculus with Limits. We're in Chapter 1, Section 1. All right, I'll see you for Lesson 2.